Hi, hello guys, welcome back to my channel. In today's session, I will walk you through on solving this question, paper one question. This video will be in parts because I want to solve all the questions in this exam paper, and to prevent the video from being too long, and I'll divide it into sections. So this video will be the part one of this section, and I will start with question one. Okay, now the question states convert the unsigned binary integer into denary. So that means to convert it back to base 10, right? And so the number is 0, 0, 1, 0, 0, 1, 1, 1. So to convert to base 10 from base 2, which is binary, so we have to write the place values here. So the place value of this is 2 raised power 0, which is 1. 2 raised power 1 is 2. 2 raised power 2 is 4. 2 raised power 3 is 8. 2 raised power 4 is 16. 2 raised power 5, 32. 2 raised power 6, 64. And 2 raised power 7 is 128. So you always put the negative with the 8 bits. Okay. So this is now 1 plus 2 plus 4, then plus what? 32. Okay. So 4 plus 2 plus 1 is 7, and the answer is 39. I hope this is understood. Now the next one, binary coded decimal. To solve this, you group it in a number of fours. This is the first 4-bit, next 4-bit. So when you are asked to convert a binary a binary coded decimal into denary, you group the binary numbers into binary digits into a group of 4, and you convert each of them back to base 10. Okay, so 0111, don't forget 011 is 7, there's 2 raised power 0, 2 raised power 1, 2 raised power 2. The normal way you convert to base 10. Okay, so this will be 7 and this is 2, so the answer is what? 27. Okay, good. After getting that, the next one is convert the 8-bit 2's complement binary integer into denary. 2's complement is telling you that this number is already in the 2's complement. That means it's a negative number. Okay, so you have to put that at the back of your mind. So the number is 111001111. So 2 raised power 0 is 1, 2 raised power 1 2, 2 raised power 2 4, okay, 8 16, 32, 64 minus 128. Don't forget, calculator is not allowed. So you start to multiply. Okay, so this gives us 1 times 1 is 1 plus 2, okay, plus 4 plus others will give 0. So you don't multiply the ones that give 0. Then this is what? This is 32, and this is 64, and this is minus 128. Okay, so all these values here are 7, and this is 32 plus 7, which is what? Which is 39. Okay, 32 plus 7 is 39. 39 plus 64 is, that is 90. No, that should be 103. Yeah, because 4 plus 9 is 13. Okay, so minus 128 plus 103. So you can just write 128 minus 103, which is 525. So since it is minus 128, that means this will be negative 25. Okay, so the answer is minus 25. So you must understand the techniques to do this because calculator is not allowed. Perform the following binary subtraction, show your working. Okay, so we do this subtraction the same way we do it in primary school. 1 minus 1, 0. 1 minus 0, 1. 0 minus 1 we say is impossible. You need to borrow a 1 from a number that is not 0. So we have to borrow a 1 from this one. Okay, when you borrow a 1 from this one, what is left? 0. So don't forget, the one you borrow is a 2 because we are working in base 2. Okay, so the one we borrow is a 2. So and that 2 will be added to the next number, which is this 0. Okay, so 2 plus 0 is 2. So that means the number is 10. Instead of writing a 2, you write it in binary. Okay, now this is a 2. but this is the operation we want to perform on, not this. So we will borrow another 1 from this 2. Okay, when another 1 is borrowed from this 2, what do I have left? 1 is left. The 1 you borrow is a 2, so the 2 will be added to this 0, isn't it? So 2 plus 0 is still 2, and that is 1 0. 2 in binary is 1 0. Is that understood? So 2 minus 1 is 1. I hope this is well understood. 1 minus 0 is 1. 0 minus 1 is impossible, so you borrow a 1 from this 1, remainder 0. The one you borrow is a 2, so add 2 to this number, that will be 2, isn't it? Which is 1 0. So 2 minus 1 is 1. Is this understood? 0 minus 1 is impossible. You cannot borrow a 1 from this 0. You borrow a 1 from the last one, right? When you borrow a 1 from this one, it remains 0. Like I said, the one you borrow is a 2. So that 2 will be added to the next number, which is 1 0, because 2 plus 0 is 2, isn't it? Then you will borrow another 1 because we want to perform this operation and not this. You will borrow another 1 from this 2, remainder 1. So the 2 will be added to this 0, making 1 0, because 2 plus 0 is 2, isn't it? So 1 0, which is now 2 minus 1, is 1. 1 minus 1 is 0. 0 minus 0 is 0. Then this is a subtraction. I hope this is well understood. Good. So let's move to the next question. Give one similarity and 2 differences between ASCII and Unicode character sets. So there are several similarities between ASCII and Unicode. So one is both represent characters using unique code. The code used to represent a character is different from the code used to represent another character. Is that understood? And both can accommodate 8 bits in the representation of what? Of characters. I hope you understand that. Then both the Unicode contains all the characters the ASCII also contains. So these are some of the similarities between ASCII and Unicode. Since we are asked to state one, then we can only write one. Okay, there's no need of writing more than one, since we are only requested to write one. Okay, so we can write that both Unicode and ASCII represent characters using a unique code. Is this understood? You can also write that both can accommodate 8 bits in character representation. You can also write that Unicode contains all characters that the ASCII contains. Is this understood? So you can also write that. So 2 differences, okay? 2 differences. One difference is that Unicode can only represent one language. ASCII can only represent one language, while Unicode can represent different languages. That is one difference, okay? Now, only one language is represented in ASCII, okay, while Unicode can represent different languages. Is this understood? Now, one other difference is Unicode can accommodate up to 32-bit characters, okay, while ASCII can only represent 7 to 8-bit characters, okay. So Unicode can accommodate, okay, accommodate up to 32 bits per character, while ASCII can only go up to 7 bits or 8 bits. Okay, so these are the similarities and differences between ASCII and Unicode character sets. I hope this is well understood. Now, the next question, it says, sound samples are recorded and saved in a file. State what is meant by sampling rates. So this sampling rate it can be explained when you are trying to convert analog sound into digital sound signals. Okay, because analog sound cannot be saved directly into a file. It can only saved as a digital file. So the sound we say, or what I'm saying presently, is an analog signal. For you to save it into a computer system, you need an analog to digital converter, which is ADC, to save this sample. Do you understand? So in saving this sample, the rate, the number of samples you now take per unit time. Again, the number of samples you take per unit time is what is called sampling rate. So while trying to save your analog signal, okay, into its equivalent digital form, okay, so is a function of what? Is a function of time. Do you understand? Is a function of what? Is a function of time. So the number of samples taken while converting into digital per unit time is what is called sampling rate. So what is meant by sampling rate? So sampling rate is the number of samples taken per unit time. Is that understood? You can also say is the number of samples taken per seconds. It's still the same thing, okay? Now the next question, explain the effect of increasing sample resolution on the sound file. Now to understand sampling resolution, like I said earlier, when the sound I'm saying, what I'm saying is an analog signal. If I need to save this as a file into a computer system, it must be saved as a digital signal. Okay, as a digital signal. And this digital signal is what? Is 1 and zeros. Okay, it will be 1 and zeros. And this is an analog signal. Then we need a device, ADC, which is an analog to digital converter, to convert this analog signal to what? To digital signal. So how does it convert it? It converts by representing this analog amplitude as what? As bits. The amplitude. This is the amplitude, okay? This is the variant amplitude. It represents that as what? As bits. So the number of bits that is used to represent this analog signal is what we call sampling resolution. I hope this is understood. So before this question is answered, you must understand sampling resolution, okay? So which is the number of bits used to represent the sound amplitude. And it can also be called what? The bit depth. It can also be called the bit depth. Is this understood? In terms of sound wave. Now, when you now increase the sampling resolution, how does it affect the sound file? Number one, when you increase the sampling resolution, that means you will increase the number of bits per sample. That is what it means. It means that the number of bits, the number of bits per sample is increased. Do you understand? So which will, as a result, increase the file size. Do you understand? So when you increase the sampling resolution, the number of bits per samples will be increased, and that will also what? Increase the file size. Now, if you have a lower sampling resolution, the sound file that will be saved on your computer system will be far less accurate. When we say less accurate, that means it will be far different from the original sound. So the way I'm talking now, if the sample resolution is so low, the sound that will be saved on my computer system when it is played will be far different from my original sound. I hope you understood. But when you increase the sampling resolution, it will be close to what? To my original sound. That is, it will be close to the accurate, although it can never be 100% accurate, but it can be very close to the accurate, to the original sound. So when you increase the sampling resolution, it makes the digital waveform, which is this, be very close, do you understand, to the what? To the original, which is the analog waveform. So that is the second effect. Since this is 2 marks, that means you must write 2 effects. Okay. Now in writing that, you can write that the digital waveform, okay, will be closer to the analog waveform, which will make the sound file, the sound file very accurate or more accurate. I hope this is understood. So that is the end of that question. So after solving the questions, let's take a look at the examiner's report for this question so that we can learn from other students' mistake and prevent us from making that mistake. Okay, now key message. Let's go to the general comment. If a question asks for a given number of answers, such as 3 reasons, only the first 3 reasons given in the answers will be marked. It is not unusual for candidates to include several extra answers, even when the answer space was numbered appropriate. Questions about number basis and comprehension were usually completed successfully. Questions about the components of CPU and protocols were more challenging. So what does this imply? If you are asked to give 3 reasons for an answer, only the first 3 reasons will be marked. Others will not be marked. So what does that imply? For example, if you take a look at this question, if you are asked to explain the effect of increasing sample resolution on sound file, so 2 reasons are expected. Some candidates will first write what is sampling resolution. Instead of writing the effect of increasing sampling resolution, they will start writing sampling resolution is this, is the number of this. You start seeing them writing a lot of stories. After writing all the stories, then they will now start writing the effect of increasing sampling resolution, which is exactly what you see in that comment. Is that understood? Then another thing is stating one similarity. Instead of stating one similarity, you see students writing definition of Unicode. That Unicode is this. They will start defining Unicode or start writing some stories about Unicode or writing some stories about ASCII and what ASCII is used for, instead of writing the similarities. After writing that, they will now start writing one similarity and the differences. I hope you understand that. So the comment is, the examiner states that if a question has to give number of answers, such as 3 reasons, only the first 3 reasons will be marked. Then apart from that, you see students writing more reasons, like 5. If this question is asking, like for example, the question is asking for one similarity, like I told you, there are 3 similarities that I wrote here, but I did not write this as my answer. I only wrote one. Those told you other 2 you can write if you don't want to write this one. But you see some students writing all the 3 reasons. What if the first is wrong and other 2 is right? Then the first one only will be marked, others will be ignored. So you must be careful about writing extra points. Go straight to the point and write what is expected of you instead of writing extra. I hope this is well understood. Now, so let's take a look at question 1. For question 1, the question was answered well. Most of the candidates correctly converted the unsigned binary into binary, which is very simple. The question was also answered well for the BCD. It was also answered well. Now, for the third question, which is III, which is the 8-bit complement into binary. some candidates found converting the 2's complement binary integer into denary challenging. A popular incorrect answer was 231, where the binary value has been treated as unsigned integer. So that means that those students have forgotten to write minus 128 as the last bit. Like I always tell my students, the last bit should always be minus 128. With this, you will not forget to treat it as what? As a negative number. I hope you understand. And even if you write minus 128 as a negative number, since you are multiplying by 0, it still does not affect your value. So those students might have forgotten to write minus 128, which will completely change the answer. Okay. Now, question 1b. For this question 1b, which was this subtraction, the question was not answered well. Some candidates need to understand that when the question asks for subtraction to be completed in binary, no working marks will be awarded for converting the binary to denary and then performing the denary subtraction. So what most students do is they convert this to base 10, this to base 10, subtract, and then convert back to base 2. This question is 2 marks. So no mark would be awarded for that working, because the question is trying to test your ability on binary operation and not denary operation. So doing that, you will not get the mark for the working. So this question was not answered well. Some candidates need to understand that when the question asks for the subtraction to be completed in binary, no working mark will be awarded for converting to binary, for converting the binary number to denary and performing a denary subtraction. Some candidates correctly completed the subtraction in binary but showed no evidence. Can you see? If there's no evidence, you won't get the mark for working. In order to achieve the working mark, the method of working must be clearly seen. I hope this is understood. Then for the question 1c, the question was answered well for question 1c, which is similarity and differences between ASCII and Unicode. So this was answered well. Then the next one, which is DI, which have to do with the sampling rate and sampling resolution. There were many good answers to this question. Some candidates need to understand that imprecise statements such as the sampling rate is the rate of taking sample is not enough as the level of this study. So writing that a sampling rate is the rate of taking samples. So what is that rate of taking sample? Is the number of samples taken per unit time or taken per seconds, not the rate of taking sample. So this is not sufficient for you to earn your mark. Okay. Now, this question asks about sampling resolution, whereas the precise question asks about sampling rates. Some candidates need to ensure that they read the question carefully. A popular incorrect answer explained the effect of increasing sampling rates on sound rather than sampling resolution. So some students were answering questions based on sampling rate instead of sampling resolution. I hope you understand that. So sampling rate is the number of samples, while sampling resolution is the number of bits used to represent. So you must identify and understand the difference between these two concepts before you answer this question, which is one reason most students got this wrong. So I hope this is well understood. I will solve this other question in the second part of this video. So see you in the second part. Thank you for your time.